This is a PID control system demonstration. It allows people and students to learn how to tune the PID gains and intuitively understand how PID works. Okay, so here, this is a floating ball. The fan is the actuator. Obviously, we control the speed of the fan. We have a sensor here that measures this distance, and the control system wants to keep the ball at this point right here. And here we can see the desired altitude, the green, the dashed line, and the actual altitude. Here we can see the PID gains. So right now, I'm going to I'm going to play with the gains right here to stabilize the ball. So from my experience, maybe I'm going to reduce the I a little bit, maybe reduce the D. Increase the I. What's going on? So okay. See now that's stable. And then there's more to it. We can see that the desired altitude equals the actual. It's very stable. We can use these switches to remove the PI. We can remove the gains. For example, we can make a PI controller by turning D off and then see how it reacts to disturbance. We see right now it's not stabilizing because there's no D term. Actually, it's stabilizing very slowly. We can make it a PD controller. We turn I off and we give it a disturbance by blocking the airflow. So this is kind of like an impulse response. Anyway, the effects are not very strong here, but the last thing we want to highlight is that why do we use feedback control? Because we can combat disturbances. For example, if I make it harder for the air to escape, the fan will work harder to bring me back to my set point. So my finger is a disturbance, right? So it's like, for example, cruise control, keeping a constant speed, and the car goes uphill. So now this is a disturbance. It's harder for the engine now, and the engine has to work harder to keep the speed. So the levels on a cruise control, for example, are disturbances, and so is me making it harder for the air to escape. That's a disturbance. So maybe that's too aggressive. So now the PID controller is able to compensate for my finger blocking the air, and it controls the height. And if I make it easy for the air to escape, it also controls the height.